Quite a bit of activities going on board the station today, but not only inside but also outside, as this week station controllers here on the ground at the Goddard Space Flight Center have continued some work that they started earlier this spring with a payload on the outboard truss section of the International Space Station. This marks the second round of testings for the Robotic Refueling Mission. And joining me now on the phone from the Goddard Space Flight Center is Jill McGuire, who is the Robotic Refueling Mission Project Manager. Jill, I want to thank you first off for joining me today, and was hoping maybe you could give us a quick overview of the Robotic Refueling Mission real quick and what you guys accomplished a little bit earlier this spring.
Yes, great. Thank you for having me. I appreciate the time to talk about the Robotic Refueling Mission. We're very excited about everything that's been going on station. The main objective of the Robotic Refueling Mission is to demonstrate that we can manipulate standard satellite interfaces that weren't designed to be done robotically. So the RRM hosts a variety of different standard satellite interfaces, as well as a fill and drain valve on a spacecraft that later this year we'll do an end-to-end task to show that we can open up the fill and drain valve and transfer fuel through the fill and drain valve. But the tasks that we've been doing so far, which we started in March and then have been continuing the last couple of days, is to show that we can remove some of standard caps and valves that you would find on a satellite and cut some of the safety wire holding those caps in place.
Okay, well, I know you guys are working with the station's robotic arm, and specifically the Dexter, or the dexterous robot that likes to sit out on the end of that thing. So get a little more specific if you can. I know there are a number of tools on board the Robotic Refueling Mission. What are some of the tools you guys have been working with this week?
Okay, this week we have been mainly working with our multifunction tool, the SPDM robot on the International Space Station. We started on Tuesday night of this week. The robot removed the SPDM robot removed the multifunction tool from the RRM housing, and we went to pick up a series of different adapters that we have on board. The multifunction tool is basically like a standard socket wrench that you can change out different sockets on the ground. Well, we have a multifunction tool that can change out different adapters on board. So the SPDM robot pulled out the multifunction tool from the housing and then went and picked up the first adapter, which we call the T-valve adapter, and successfully removed the T-valve from the panel and then stowed the T-valve into the receptacle. The only tool that we intend to use during this go-round is the multifunction tool. We have 3 other tools on board: a safety cap removal tool, a wire cutter tool, which we used to do the tasks in March, and then we have a refueling tool that we'll use to do the refueling task later this year.
Okay, and we're taking a look at this animation right now, and again, this is all controlled robotically from down here on the ground. It's pretty fascinating stuff. And I believe we're looking at the multifunction tools, so it's going through and removing a system of caps and cutting wires, and these are all things that you would expect to find on a satellite, and these are things that aren't built to actually be manipulated.
Correct. So the whole goal of RRM was to show that we can build an innovative tool to bridge the gap between the end of the robot and the satellite interface that wasn't designed to be manipulated robotically. So the first task you see in the animation was the T-valve, where you saw the multifunction tool grab the T-valve adapter and move the T-valve. The second thing you saw in the animation was the multifunction tool grabbed the ambient cap adapter, and that happened last night. We successfully removed the ambient cap and restowed it into its receptacle. And then also last night we grabbed the plug manipulation adapter and released it from its receptacle. And later today, when operations resume, we will then transfer over to the payload and pull out a plug that is down inside the receptacle where the ambient cap that we removed last night is. There's now a plug that's housed inside there. We want to show that we can robotically remove that plug. So the plug manipulation adapter is designed to insert a probe down into the hole of the plug, and we will retract that plug just a few inches, not, or I mean, half of an inch about, it is safely controlled so that we don't have any debris flying on station, but we will be able to show that we can get it past the O-ring that is installed in there.
Okay, and as you mentioned, this is all kind of in preparation of some upcoming activities later this summer where you guys are actually going to be transferring some fuel over. Can you give us a quick preview of what's going to happen when that occurs?
Yes, the hope is in the end of August we will get scheduled for another set of operations, and we have a standard fill and drain valve or a fueling valve on a spacecraft on board the RRM, and it is fully closed out like you would find it on a spacecraft. Before a spacecraft launches at the Cape, they fill the spacecraft with hydrazine, and then because hydrazine is so highly combustible, the fill and drain valve is closed out with a series of caps, and the caps are then closed out with a series with safety wire in order to ensure that the valve does not open during launch. So once that's all great for ground safety, but now if you wanted to try to refuel that satellite in orbit, you have to be able to cut all that safety wire and remove all of those caps. So in August, we will start one by one. We will cut the safety wire on the tertiary cap, remove the tertiary cap and stow it. Then we will cut the safety wire on the safety cap, remove the safety cap and stow it. And then we will, the SPDM robot will acquire our nozzle tool. The nozzle tool will interface to the fill and drain valve, and through a series of operations using the torque advance on the OTCM, the end effector on the SPDM robot, we will then be able to acquire the thread onto the fill and drain valve, open up the actuation nut, and transfer fuel through that interface. So we have a half a gallon of ethanol on board in our fuel transfer system that the back half of our payload has the fuel what we call the fuel transfer system. It has all of the required hardware to pump and transfer the fuel through the interface.
Okay, well, we are definitely going to be looking out for those operations when they occur a little bit later this summer. And just kind of as a conclusion, what kind of missions could something like this enable in the future? I mean, robotically refueling satellites isn't something that we really have the capability to do right now. What kind of possibilities would this open up?
Well, the goal is that once we can demonstrate the technology on space station, that we buy down the risk for future applications such as any government or commercial birds that would need refueling. We could extend the life. We could robotically interface to that spacecraft through like autonomously grabbing on to, say, the launch adapter ring or the Marmon ring. Then once we acquired that satellite, we could then go through the robotic operations similar to what we're doing on station. We can go through the robotic operations to refuel the spacecraft, or we could, in some cases, maybe repair or deploy an appendage that didn't deploy, such as a solar array that got stuck after deployment. We could go and grab the solar array and do a final deployment of that. So the idea is that we could change the paradigm of satellite servicing, where we could then send a robot vehicle up and do this with a robot and extend the life of spacecraft, either again by refueling or servicing them. And the hope is that we will also be able to aid in like the future exploration goals of NASA, when to have robots and humans working together in space, where you can extend the time that you can have servicing and exploration done with robots doing the jobs while the astronauts are sleeping, similar to what we're doing on the International Space Station. You can have accomplish more in a shorter amount of time by having the robots and the humans working together. So we're hoping by doing these demonstrations that we're enabling the technology to move forward and do these things outside of space station, in low Earth orbit or in geosynchronous orbit, or places, asteroids, places where further exploration where NASA wants to go in the future.
So really just adding a whole nother dimension to human spaceflight, even though everything's being controlled robotically, and also giving a lot of satellites a second chance at life and potentially saving, millions of dollars of replacing satellites for communications and any function that satellites are put into orbit for nowadays. Well, Jill, I want to thank you for coming on with us today. We're really excited to be following along with the robotic refueling mission. We'll definitely be looking out for you a little bit later this summer when you guys actually start fueling up.
Sounds great. Thank you so much again for the opportunity, and thanks to the robot operators at Johnson Space Center and the Canadian Space Agency who have been doing a wonderful job working through all of our tasks and being so successful in accomplishing all of our objectives.